gentlemen, let me welcome you this day to this webinar being presented by the Jamaica Institution of Engineers. So I welcome our esteemed panelists and fellow engineers and members of the public, especially those of you who are joining us at the JIE for the first time. And this is our first webinar for the year. And this is being hosted by our Mechanical Engineering Division. The theme this year for the JIE is engineering, the driver of manufacturing, production, economic growth, and health. So in tandem with this theme, the different divisions have several events that they will be hosting. Events, webinars, as well as activities, which is geared towards helping our industry, their leaders and the engineers in improving our production, our efficiency, and our effectiveness in the different industries through the use of engineering knowledge, through the applications of its techniques and its systems. The theme for this discourse that we're having today is asset management using predictive maintenance for productivity and profitability. So on behalf of the council for this year, I'd like to thank you, and we encourage you to stay with us for the short 45 minutes and session. And we hope that the takeaways, you will be able to utilize them in your different industries. I now hand you over to engineer Shauna-Kaye East Bevan, who is the chair for Mechanical Division. Shauna, it's over to you.
Thank you, President Boyd, and good morning again to all the persons who took the time out to be with us today. So as persons in manufacturing, we're all manufacturing related in some fashion or form. We speak a lot about non-productive time, downtime, equipment availability, uptime, productivity, and of course, all of that is linked to our profit line or profitability, right? And within our various organizations, we have deployed
Just unmute for us and continue again, Shauna-Kaye.
So sorry. It's a probability that equipment will do what we want it to do in a specified time. And the panel that I have with me today are so equipped and experienced to share with us why we believe predictive maintenance is a key enabler for productivity and profitability within the manufacturing sector. All right, I'm going to hand over to our moderator for today's session, Mr. Michael James.
Thank you very much, Engineer East Bevan. My name is Michael James, graduate member of the Jamaica Institution of Engineers, and I want to extend my welcome to everyone who has joined us for today's seminar or webinar. Right now, before us, I have a panel of experts in the field of predictive maintenance, and they will be discussing with us asset management through predictive maintenance and condition monitoring that will be profitable and productivity drivers in your organizations. Now, of course, if you haven't sent out the webinar link and everything like that, send out to everyone at this moment. We're about to start, and I encourage everybody to kind of join in and, that they can learn and experience what we have here this morning. Now, allow me to introduce a few of our panelists for you now. All right, our first panelist is Edward Mendez. Right, he's a certified predictive maintenance and signature analyst. He's certified as a project practitioner by the American Society of Advanced Project Management. Edward was certified for a period as a reliability and maintenance professional by the Society of Maintenance and Reliability Professionals, and he has 20 years of experience in maintenance, and he also holds a Master of Science in Maintenance Management. Now, also with us, we have Shauna-Kaye East Bevan. She is a maintenance manager She is former senior reliability engineer. She, of course, is a registered professional engineer in the mechanical division, and she's a certified energy manager, also a certified maintenance and reliability professional. And of course, she is the head of the mechanical division of the Jamaica Institution of Engineers. Also joining our panel, we have Mr. Rossi Ramsaram. Rossi Ramsaram is a certified vibration analyst, laser alignment and prediction balancing by Mobius Institute, tank cleaning system from the Butterworth Company, his GE certification in generators and fluid pumping systems from the Askew Pumps in the UK. He also has a Master of Business Administration from the Anglia Ruskin University, inclusive of project management with special emphasis on leadership and innovation. And our last panel member for this morning is Vansy Brown. Vansy Brown is an electrical reliability engineer, ITC certified thermographer, AVO trained transformer analyst, PDMA trained transformer analyst, PDA certified motor analyst, GER certified electrician, ultrasonic trained. He's a certified reliability and maintenance practitioner. And all of that is a mouthful for our different panelists. So I'm sure we're in tune for some very, fruitful information from each and every one of them. Now, I'll give each panelist a few minutes, to delve into their field of expertise and discuss a little bit of predictive maintenance. So let's begin with Mr. Rossi.
Hi, good morning. Thank you, Michael. Pleasant good morning to everyone. So I am the owner of Genesis Industrial Solutions Limited in Trinidad. And as I deal today, we're here to talk about asset management and predictive maintenance. So I have a slide that I would like to go through, a PowerPoint presentation that should divulge some new knowledge in the field. Okay, so is everyone seeing this slide? All right.
Yes, we're seeing the slide. Yeah.
So asset management, specifically with the mechanical engineering section, employs various technologies as we here to discuss, some of which are vibration, infrared tomographics, motion amplification, discharge frequency testing, and Lubboil analysis, Lubboil testing. So these are existing technologies that we can use and can employ in the field to give insight into the asset management and the future management of the equipment. So this is an interesting one. Asset management actually falls under an ISO standard. The standard is the ISO 55000 series, which includes version 1 and version 2. Asset management standards are guidelines as to how assets should be maintained, and it was actually published in 2014. This standard gives an overview of the benefits of asset management systematic strategies, as well as ways to integrate assets into the CMMS systems. Part of the ISO standard speaks to the condition monitoring and predictive action, which is directly governed under another ISO standard, which is the ISO 17359, which specifically speaks to condition monitoring and how it should be ideally done. So my main business is in the field of vibration analysis. So vibration is actually governed under an ISO standard as well, which is 18436-2 of 2014. And vibration analysis is the process that monitors both frequency and amplitude of a machine, enabling the analyst to see current issues arising, as well as attempt to predict failure using trends of previous data collected. This technology can detect and assist in the prediction of the following, but is not limited to imbalance, misalignment, bearing wear, lubrication faults, gear wear, rotor rub in motors, and both structure and mechanical looseness. By using an accelerometer, which captures analog signals that is then converted into electrical waveforms, we can now allow equipment to speak for themselves and tell us what is wrong. As we as professionals in our field can now make informed decisions based on what the equipment is saying for themselves. Just a thing, can you imagine if an animal can speak, right? If we can speak the language, the quantum of knowledge that will be gained. Similarly, with our equipment is speaking to us. And we need to process, we do possess the technology to interpret and understand, hence the importance of vibration analysis, as well as the unfathomable knowledge that we can gain by employing this existing technology. So this exists, we utilize this throughout the oil and gas in Trinidad and in the manufacturing sector as well. So predictive maintenance, guys, it has phases, right? So predictive maintenance carries an algorithm which must be followed to prevent costly downtime. We at GISL have had clients which employ predictive techniques, and after the information was passed on to management, it wasn't used. It resulted in over $150,000 in downtime and productivity loss. Simple failure can cause a simple problem could cause a catastrophic failure, right? And reason for this is this was actually in the maritime field. So this algorithm that we utilize and we encourage is to test, detect, trend, plan for a repair or conduct a repair based on what the data is saying, retest, conduct a root cause analysis, and then trend it again. So you can see from the above, both testing and trending is completed twice. This is to ensure validity of the equipment to be presented to management both before and after the repair. This mitigates the infant mortality of equipment due to faulty repair, and the largest time gap for mortality is preceding a repair, as indicated on the Bartel curve, which is actually the transparency behind. So this is my short slide, guys. If you all need any further information, feel free to send me a WhatsApp message or an email message, and I will be happy to assist anyone in how they could move forward in doing some analysis within their plant.
All right, thank you very much. Thank you very much. All right, while we're in that realm, that mechanical realm, and more specifically root cause analysis, I want you, Edward, to kind of weigh in. Tell us a little bit more. All right, Edward, you're with us? Yeah, man.
Good day, everyone. So I'll be doing a mechanical outlook. I have some slides that I'd like to share as well to clarify what I'll be going through. Let me just go ahead and do that. Just give me a minute. Okay, so some mechanical outlook from predictive maintenance. And predictive maintenance technologies, if employed to your industry, can lead to productivity and profitability for your company. I'll share with you why that is the case. So predictive maintenance technologies lead to effective maintenance planning by early detection of equipment failure. Of course, it's allowed for offsetting the lead time for items. For example, you need to buy a bearing, or you need to buy a part that is not locally available. If you have a failure, I'll go into example. If you have a failure and the equipment fails suddenly, then you lose production. Then you'll have to, at that point, try and procure the parts, which that lead time now is added to your downtime, and that's a lot of money. So what predictive maintenance does, and for example, this is the Ultra Pro, it can actually take bearing failure weeks in advance. So that leaves you the opportunity to do proper planning, because now the PM technician will say, okay, this bearing will fail in 2 months' time, and your lead time may be a month. You can get all the parts you need to get prepared, plan properly, have a detailed downtime that is planned for, and at that point now your productivity is not at a loss. Profitability, and I'm not a profitability. Predictive technologies can reduce repair maintenance costs for operating equipment. And I'll give you an example. So a gearbox typically has an input shaft, output shaft, and it will have a high-speed or low-speed gear and some intermediate gears in between, 1 or 2, maybe more, right? So what predictive technology does, in this case, you have a bearing failure in a gearbox, and the PM technician can say to you that it is the bearing on the low speed gear or it is the third gear. And based on that, now you can go and buy that bearing while the equipment is still running, rather than take out the equipment and change all the bearings. Because when you if you take out the equipment and carry it to a repair shop, they're just going to change everything. So overall, but if you're a technician can say that particular bearing has a life of 4 years, that has a life of 3 years, but this one will fail in 2 weeks, you can be very specific as it relates to your maintenance. In fact, the very small shaft you see there, the high speed bearing, that generally those bearings would go faster because that air spins a lot faster than everywhere else. And most gearboxes are designed that you can actually pull out that part section only. So you may even have the opportunity of not removing the entire unit, but just taking out that portion, get it repaired, and you're back up and running with productivity. So you won't lose in terms of finances, in terms of production loss, and that leads to profitability. Further to that, predictive maintenance technologies can also lead to innovation and re-engineering. And we have an example of this that I'll share with the team, where you can reap significant savings, right, from a maintenance cost. So I have here a split casing pump. So most of you will be familiar in industry. What a pump is, you move fluid from one point to the next, right? So every industry will be moving some form of fluid around, and that requires a pump. So this is a split casing pump. And this pump is designed, let me just share the next slide. It is designed to be balanced axially because it's a double suction, as you can see in the notation there. So from the design stage, the designer say, okay, this pump will only need to account for radial load. Radial load is load perpendicular to the shaft and not in line with the shaft. So what I found in one scenario was that the predictive tool, the vibration analysis, was showing high axial forces all the time, and we had bearing failure for that reason. So based on the data that was collected and looking deeper into it, my team and I decided that we could make a modification that would save, because when this pump fails, so just a background. So when you design an equipment, you design it based on what its intended purpose is. And by all means, expectation would have been that food is entering at both sides, it will be balanced. And that is really true. Except that if the pump is in an area where there's cavitation or there's blockages, then the load is no longer balanced, and that's how you get axial forces, right? And then you have bearing failure. When the bearing fails, as you can see there, the clearance from the impeller, that bronze looking middle section, the impeller would move and rub into the casing, and then you lose the impeller, lose the casing, and you have a regular bearing and seals to change out. So the cost becomes very high, and I'll show you what the cost is like in a minute. So what we moved from, for this pump, based on just predictive maintenance information, move from the single row radial bearing that was just equipped for radial load and remove to angular contact bearing. If you notice, the bearing is designed a little different. So if the shaft should try to move inward, the bearing will support it and it will not fail. And this bearing, the ball is designed to run along that curvature of the outer race of the bearing. So what the final design looked like, just for example. So typically what we had is two angular contact bearings. So if the pump tried to move left or right, it will be protected. And so based on that, there was a lot of savings in terms of not having a failure where you lose the impeller and the casing, right? And I'll just give you an example of what the impact was like for that one. So the casing alone typically is 75,000 US. The impeller is 25,000 US. The bearing and seals were total roughly 10,000 US. I know Rossi had mentioned earlier about $150,000 scenario is actually a real scenario. This was less though, but it worked out to US 110,000. This didn't include other consumables. So, and that works out to 17 million Jamaican dollars. Now this is just one pump. So this is what predictive maintenance technology can offer for your industry in terms of profitability and productivity. So initial costs of predictive maintenance can be intimidating, right? Because you think about the startup costs and to buy the technology, but there is a solution for that. Where the startup cost is an issue, services can be procured through consultancy, right? Because this way you don't need bear the high cost of the technology, and also, in case we don't have the expertise, and these services we can provide. Thank you.
All right, thank you very much, Mr. Mendez. All right, I want to remind all our participants that you can ask your question, you can pose your questions in the question and answer section of our meeting. And then of course, after each panelist have, discussed their area, then we'll, look at the questions and ask the panelists after. All right, so thank you very much again, Edward. All right, and now we're kind of switching it a little bit into the more electrical side of the predictive maintenance. All right, so this is your section, Mr. Vansy.
Good morning, team. Good to be here. Let me just share my screen. Okay. All right, good day. As I say, good day. We're talking about electrical predictive maintenance technologies in mechanical field. You are all experienced, know that we need electrical to drive the mechanical. And
I don't
also
think we're seeing, don't think we're
Before
seeing
you,
your correct
yeah,
screen.
yes, yes. Are you seeing my?
so go on the PowerPoint itself, Vansy.
On the power. Hold on.
There we go.
Okay, hold on. Make it back to All right. Now you're all seeing my slide, just to confirm.
Perfect.
Okay. All right. My main focus this morning will be on the electrical thermography and motor testing side of the support to the mechanical PDM. This is a wide cross-section or wide base of what we can do. So I'm just going to keep it narrowed down to the electrical PDM side of things, ready with the motor and the thermography. So what is electrical predictive maintenance? This is predictive or condition-based maintenance, and it is a highly effective method to detect possible symptoms, because just like everything else in the industry, before it fails, it goes out. Energy cannot be created or destroyed, so it moves from one form to another. So hence, we can see these failure signs and pattern and symptoms represented by heat. We also, it takes to catch this, it sounds good and all, but to capture and to make the most of this technology, we have trained people practicing in the field with a background, scientific background, engineering backgrounds, to us. These persons will assess conditions or based on equipment, operation, design, and how it's operated. So electrical predictive maintenance involves the use of the PDM technologies. These equipments are often used to diagnose, evaluate the condition of the assets. And when you do that condition monitoring now, we use it in two ways. We use it as a baseline or use it as trending tool. But to get the most effective part of it, we have to trending, because you do the initial test, then you assess how your equipment operates over a period of time, and that will tell you your equipment health. As it says, condition-based. And this is where the saving comes in terms of total replacement. You replace the condition, based on the condition of the operating time, design, and how you're using it, and how effective it is to you. This is widely, the application for this is wide. The military use it, they use it in medicine, they use it in engineering, and also in meteorology. This is a screen here of infrared thermography. Yeah, there are different applications of it. We use it in the electrical field as AC systems, where we test for heating, and also on the flip side, not every equipment was made to run hot. Some of them will look for cold spots too. We use it for the fluid analysis in terms of circulation of fluids and all that. In the transformer, we use it for test of cooling efficiency, where we look at the cooling pattern and the heat profile. We use it to detect wear, rusting, delamination, aging, those things. It's wide. Also allows temperature readings to be collected from distance without touching or going anywhere near the equipment, because in the electrical field, don't want to touch to really find the condition. So also, this technology, we have cameras that can go up to 50 meters at a right away of temperatures. The data is then used to schedule a timeline by which you should design servicing or prescribe servicing. But one major disadvantage you have in this field is that the surface has to be a non-reflective or least reflective or close to the black body. So there are different surfaces that emit differently because they're using radiation. So a shiny surface would not be very well represented on a temperature profile. On this, we have an example here in the electrical field. You see that bright spot glowing there, that is a spot that's saying that, hey, we have a problem here. This spot may be a loose joint, or this color joint based on previous failure, but what the analyst do, it uses trending to decide what is happening here. It could be a simple thing that one phase is loaded more than the rest, so it doesn't mean that this has to be a fault. That's where analysis comes in and trending, but looking at it, this jumps out, so there is a fault on the spot number 2. Also, and the next arm of this, you guys have covered pumps and those things already. Let me just touch on the motor side of things now. Very important, even though you might overlook it. But in motor testing, we use an equipment called MC Max Tester. That equipment is equipped to do resistance testing, insulation testing, power circuit testing, power quality testing, stator rotor testing, a wide array of testing, and it works. This is not your traditional flow chart, but it's a method of operation which will keep you on the best practice path. So I'm going to read through this slowly for you to get it, because this is what I really wanted to understand from motors. The motor circuit analysis uses a technique known as electric signature analysis to find anomalies in the motor. Anomalies meaning air gap issues, power profile issues, where the sine wave, you look at the health of the sine wave, you look at the speed of the motor, just by clamping three clamps to the motor and to this tester. In addition to analyzing the circuit and its components, it evaluates the voltage and current entering the motor. That means I can tell if the supply is clean or good intake supply coming in from the source. If you have a balanced voltage, imbalanced current, those things limit the life of your motor by cutting down your winding, operating at higher temperatures. And again, use thermographer to find these high temperature points in the motor winding. And also if the bearings are going bad, we use the temperature gun or the thermography camera, and you can find these things. When you do this in terms of the motor testing, we can do this both online and offline. So it doesn't matter the condition or matter the operation of the day. We come in, or the person doing that test, they can do it online, offline, and give you just as much result. And also NX Plus works both on AC and DC. We could go on all day, but you may have my contacts. If you want more information, I can get more detailed information to you, specifics in terms of acceptance criteria, in terms of insulation readings, in terms of temperature profiles and those things. I have a portfolio here because of practicing for over 20 years. The folder is very large, so I can share it to you if you get my email address that will be shared. Thank you.
All right, thank you very much, Mr. Vansy. All right, very insightful, very insightful. All right, and we're kind of moving down now to our, the rows among the thorn on our panel. Mrs. Shauna-Kaye Bevan. All right, she'll be discussing the very important aspect of asset management that we must consider with any strategy that we deploy. So over to you now, Engineer Bevan.
Thank you, Michael. And good morning again, colleagues. Happy to be able to share in this fashion with our professionals in the industry and engineers as we look toward preparing ourselves for the future. But we have discussed many things. We have discussed electrical predictive tools as well as mechanical predictive tools and how we can remain competitive and boost our productivity, which of course correlates to our profitability using various technologies. We've had that discussion, and now we're all convinced that we need to deploy predictive maintenance strategies. I am sure that there's no doubt in this room, but there is a caution. As my moderator mentioned, with any asset management strategy, we have to plan, right? If you fail to plan, my grandmother would say, plan to fail. So I'm going to take you through work planning as a function in enhancing the predictive maintenance strategy within your organization. Okay. All right, so the Society of Maintenance and Reliability Professionals has a body of knowledge, which includes 5 pillars. What you're seeing on the screen now is the 5 pillars: business management, manufacturing, process reliability, equipment reliability, organization and leadership, and work management. Now, I've highlighted that one for a reason, as we're going to delve into that. So work management from a rudimentary basic level is 5M plus E, and we all as professionals know what 5M plus E, failing that it is putting everything that we need to put in place: resources, materials, methods, machine measurements, and considering the environment for us to deploy a particular maintenance strategy. In lack of a better way of putting it, planning the activity, right? And in planning and putting together the framework of the maintenance strategy for any technique that we're using for asset management, and in this case, predictive maintenance, you need what is called a computerized maintenance management system or software, right? And I believe that I'm assuming that many of the visitors on this webinar are exposed, especially in industry, to a software like this. So we can implement many things, but if it's not implemented in a controlled way, we will not get the benefit. We can all agree on that. So a CMMS is, and more persons may be more familiar with an EAM, which is an enterprise asset management system, and it's more holistic. So it starts from the asset lifestyle management, the asset planning, I wouldn't say planning, asset initiation to asset disposal. Many persons locally I am aware of has EAMs in as part of their maintenance strategy or asset management strategy, but many persons just stick to CMMS, and that's more, it's more user friendly, and it's more to the point in terms of maintenance management. So the advantage of a CMMS is work order generation. If you're able to prioritize, you're able to track by equipment or components, historical tracking. And we're gonna dwell some more on that. I'll tell you why when I get to that point. Historical tracking of all work orders generated, right? You can sort them by equipment, by component. The CMMS has that, right? You can track scheduled and unscheduled maintenance. So in a sense, the predictive maintenance plan that you deploy must be deployed through a CMMS, right? Storing of maintenance procedures as well as technical documentation associated with an asset. All right, back to work management. So that's just a quick 5-step about how you start preparing an activity for execution. So you identify what activity, and that's where you get the data from condition monitoring tools. So you want to plan for a vibration analysis on a particular piece of equipment, right? So you would identify the need, then you start to plan it. What equipment am I going to do it on? When will equipment be available? How long will it take? What tools and resources do I need? How much will it cost? We consider all of that. And in some instances, that time and motion study is important so that we can be as lean as possible in terms of how we schedule and execute maintenance or predictive activities. Scheduling, of course, and of course, the execution at the culmination of the plan, all right? All right, so I chose to just sit on this slide a little bit because a lot of us have questions about costing and the intimidation of the cost to start up a program. And what I will say to my colleagues here is that there's a sweet spot. Graph is a controlled experiment, call it the ABC analysis. You start small and you see the incremental changes, and you find that sweet spot where your cost of preventive or predictive maintenance isn't the lion's share of your cost, right? You have to monitor the effectiveness of the program, the results, the cost, the benefit analysis has to be done in deploying any program. And I typically use this chart. It's a good overview of the things that you look at to determine to what extent you need to delve into the technology. You can't just jump off the cliff right away. You start small and you gauge, continue to do your custom analysis as you go along. And before you know it, you're implementing a predictive maintenance program within your organization, right? And as my colleagues mentioned, it requires a lot of training. So the future of asset management, quickly, we're in the digital age. We're talking a lot about the Internet of Things, artificial intelligence. Guess what? A good CMMS and a good asset management program and the data. Remember I mentioned the historical data there? That is the background for delving into the sphere of artificial intelligence. You need the data. The CMMS houses that data in such a way where when you are ready to dive off, the data it pulls is from the previous preventive maintenance activities that you would have done, from the condition monitoring, from the mean time between failure, because the CMMS also tracks that, and it pulls it together to give information for assessment, right? So we want to think about the future as we, as maintenance professionals, look toward raising the bar and becoming more competitive in the global environment. The world is passing. The technology itself it's skyrocketing, and we have to operate in such a way where our profitability is high and our productivity is high, so that we can remain competitive in the markets that we delve into. Left off that slide. And just a quick discussion about edge computing. Have to throw it in there. So remember, I said to you that the data that we store in the CMMS can be used to go into AI. What you're looking at is edge computing. What edge computing does essentially pull the data from the storage area, which can be the cloud as well as the CMMS, and it thinks for you. Puts all that data and thinks for you, and then it does something magical. It prescribes a repair strategy for the equipment. Think on these things. So in conclusion, we encourage all industries to improve equipment reliability, improve uptime, cut excessive maintenance costs, cut production downtime, if we invest in predictive maintenance and execute things through CMMS. So we want to also prepare for the digital age. It is coming, we cannot avoid it, right? And we have to remain competitive as a nation because we're thinking about economic growth as well and foreign exchange. If we're able to remain reliable and productive, we can compete in the foreign market and generate that foreign exchange to build our nation. And last point, predictive data can also be prescriptive. So it can tell you what you need to do to get the equipment based on the data that it collects. It's thinking for you. That's the age of technology. Thank you.
Thank you very much, Engineer Bevan. All right, a very interesting discussion you've started. You know, the digital age is now, really and truly, right? And it's an interesting aspect or important aspect of asset management as we consider, you know, the Internet of Things and, you know, Industry 4.0, right? I just want to remind our participants, yes, you can ask your questions as we, you know, open to the panel now to a few further discussions on what they presented on earlier, right? But allow me to start off a bit, right? You know, you last spoke about Internet of Things and you know, Industry 4.0, but I don't only want to hear from Shauna-Kaye, right? So you know, to the panel, right? Would you say that as a nation, we're behind the 8-ball as we prepare to embrace predictive maintenance and by extension, you know, the Internet of Things and Industry 4.0? Well, I must also add, I did not mention before, you know, Mr. Ramsaram, well, persons would have heard the Trini accent, so perhaps you can speak more so on the region, but I would love to hear everybody else on, you know, are we behind the you know, figuratively the 8-ball as we prepare to embrace predictive maintenance in regards to Industry 4.0?
I believe there are opportunities. As I mentioned in the slide, persons tend to be apprehensive and tend to be not so willing to take on predictive maintenance because it appears to be very expensive. But that's not necessarily true in all cases. As I mentioned earlier, where the expertise is not there, consultancy can be had. But further to that, during that consultancy, what you'll find is that you can start small. It could be a case where you need you can start with a temperature gun. That's the predictive. So you could have somebody just checking to see what your bearing temperatures are to know if there's a challenge there. The ultra probe, as I mentioned earlier in one of the slides, it's a very powerful tool for detecting bearing failure, and it's not very, very expensive. Considering the gains, because we looked at 17 million Jamaican dollars. We looked at their internal savings, and that's just one pump. The ultra probe should cost somewhere around $4,000 US. So persons are fearful of the cost that may come with predictive maintenance, but you can start small and reap big savings. The other part of it is, I think of a culture of run to failure. We have a culture of the light bulb situation. We keep the light bulb on, and when it blows, you change it. But there's productivity losses that come with that must be factored in. And I think we need to maybe engage persons to let companies understand that there can be significant savings, as Shauna-Kaye mentioned, in terms of the operating costs, so you can become more competitive in the global market. So some of it will be, exposing companies to this situation that like we have here. This panelist, what we have been speaking on is enlightening persons about, about opportunities. Over to you.
Thank you very much, Mr. Ramsaram.
Michael, one thing I have noticed in Trinidad and throughout where I've been is that the first thing that manufacturers do or companies do is take away from the budget for maintenance. Because a lot of times they just think of maintenance as running around, greasing some bearings, doing some checks. And they don't fully grasp the understanding as to what it is maintenance is, right? And I usually start with saying that maintenance is the means by which anything is kept functional, not only equipment, ourselves, our cars, everything else. And from a predictive standpoint, if you notice in my slide, one of the companies employed the predictive maintenance. They were given the information, but they didn't act on the information. So I think one part of it is for persons that employ the service to actually act on the service. And from a cost benefit standpoint, I mean, there's just pennies on the dollar. I mean, as Mendez also was saying just now, is $110,000 US for a pump to do the repair. And it will cost you a couple $100 to employ a consultant to do the same testing that would have given enough insight to get these things done beforehand. So in Trinidad, a lot of companies, I mean, we have the oil and gas sector, they would utilize the predictive standpoints in the manufacturing. We do a lot of work in manufacturing in Trinidad, and a lot of them actually utilize these systems, but we encourage them to trust the systems as well. Right? Utilizing it and trusting fully as to the experience. I have 16 years in the field, and that is both offshore, marine, and in manufacturing. So you need to trust these guys here that are the experts in what it is they are telling you. Yeah.
I mean, for some people, the discussion seems like it's more for larger, big manufacturing firms, right? So kind of tweak it a little bit, and what recommendations would you give to small manufacturing firms who want to dip their feet into the predictive maintenance?
All right, Michael, let me take that one. Small manufacturers, they tend to, but as Rossi said, they cut the maintenance budget first because we are faithful citizens. We are believing things we can't see, but we are conditional. So in using those words, for instance, your car, you get up every morning, you pump your car tire. It's because you've seen it look flat. Some things you can't see with your naked eye, and some things you're not experienced and on your own. If you're a small company, you can use a thermometer, a temperature gun. Those are $200 US and less. What that does, you put that on your bearing housing or on your surface of your equipment. The Monday morning, you get a temperature. You put that on it Tuesday morning, you get a temperature. You go back next week Tuesday, the temperature changes or the temperature remains the same. That is condition monitoring you're already doing. It's a simple temperature gun. Maintenance is based on your budget and your application. Also, it's most effective with consistency and accuracy. So if you're a small company, focus on accuracy and consistency, and you should be profitable. Don't have to buy a $1 million camera. You can buy a $12,000 camera. You can buy a camera based on your range of temperature unit, because the infrared cameras, those can be very expensive. But what most small companies do, they bid the job out to the experts, and the experts come in and say, based on your application, this is what will cost you, and this is what I'll offer you. Shauna-Kaye, you have your hand up.
Yes, I wanted to just weigh in on the point that you're making. It's important for us to analyze our own business environment, analyze what our resources are, and perform a cost-benefit analysis. One size does not fit all, right? And there is a point at which the excessive maintenance can strain your budget, and you would have diminished or broken down, or I would say erased to some extent the gains that you would have by strategically rolling out programs. So there is a sweet spot, and we all must consider it. Everything that we roll out in our organizations, because we have to, as I mentioned before in my presentation, remain profitable and competitive. We have to look at that margin and treat it with the due diligence that we need, that our leaders above can see the benefits for the investment.
Okay. Also, our next point for motor, basic maintenance, if you can't afford those MC Max test set, there's a company, many companies are leasing them now. They lease it, they train you to use it. And that's low, and you use a regular multimeter, a regular mega, to do your installation checks and write your figures down, train them, and you can see the difference happening. Or contact your local motor repair shops. They have equipment, they can come in and offer your service. The cost is very small compared to a loss. Just bear that in mind. So if you're worried about budget, the budget can be much smaller if we manage our maintenance better. The budget will always be more impacting and unjustified when you have failures. But in failures, we only have one choice: fix. In predictive maintenance, it's condition-based, so we can decide which week, which day, which month we're going to fix this thing before it gets catastrophic. And that is more valuable than anything else we can ever do in this field. It's just like you become a prophet in your own lifetime. So you can say, I'll take this out, I'll take care of this before this happens. And that will be very powerful in this field. And also, it's hard to sell something to people what they cannot see. So it's always good to show them the bottom line. If you do this now, this will happen. If you don't, they will see. You don't have to tell them. They will eventually see that happening. We have seen many times over and over. So we could go on all day about this, but I'll say
I just want to bring in Mr. Ramsaram on this one, right? He has his hand up, and we want to move quickly with this question. Mr. Ramsaram, your input.
Vansy, one thing, when I hear you mention to do the test, and once you start, you could put a thermometer and you would get the information and you're trending and stuff like that. One thing I want to put out there for persons that largely involved in their organization is that plenty companies see it profitable, find it profitable to buy these pieces of equipment. And when they get the equipment, they start very, very quickly. They're doing condition-based monitoring, and after 6 months, when they're not fully trained and fully knowledgeable, it just falls off, right? So they just need to be cautious in buying these equipment and the person that they give to operate, because you always need to have somebody to police the police, right? Because the technicians will do tests on certain equipment that they do repairs on and come back and tell you that it's very good when they didn't do it. And that's how we want the equipment to speak for themselves, not have the technicians speak for them.
An interesting point. Interesting point. Yeah, man. Well, I'll bring you in on this question, Shauna-Kaye. And I know Vansy would have spoken a little bit on it before about local entities, but tell us a little bit more. Are there local entities that provide these services that we speak of? How reliable are these, predictions, and what are the risks?
Right. Thank you for the question. And indeed, there are many local places that can provide that sort of service. A couple of the experts are actually in this forum. And I don't think I need to even go further in terms of talking about the reliability of the data. It takes years for a technician to develop the skills needed to accurately interpret data. It takes years. So I know that many of us are in the room saying, but how accurate is this information? How accurate is this? How can I risk operations or shutting down an equipment based on what this gentleman is saying, right? And I chalk it up to experience, training, and having that, I would say, keen eye or love for the technology, right? So a person that has been in the field for perhaps 2 years has a certain amount of experience collecting data and analyzing, but it takes several years, I believe, for the skills to be developed in such a way that your recommendation from your data collection, and I'm speaking specifically now about vibration analysis and electrical motor testing, etc. It takes years for you to develop that discernment to analyze the FFT spectrum, analyze the data in such a way where you can actually ask somebody or confidently say to a manufacturing manager that, hey, I need for you to do this in this amount of time, or you risk this. It takes years, and there are many reliable persons in Jamaica I can speak to that can provide that service.
All right. Thank you very much. Well, for my next question, well, I left school, not too long ago, and I do remember bits and pieces of learning about predictive and preventive and all sorts of sections of maintenance, right? But I think I can throw this back to Mr. Mendez. Do you know of these strategies being taught at the university level or outside of the university level, to help our people to be more aware of these strategies?
Yeah, good afternoon again. Yeah, I know UTech started a program where they were training on predictive maintenance, but I don't think that's sufficient. It's more on, more highly technical, mechanical, rather than industry type, on the job. So my team and I, since you mentioned, we actually are launching, rolling out a company to actually do this, because we recognize, as Shauna-Kaye said, that we, to be competitive globally. I mean, there's some things you have no control of. For example, the cost of oil, the cost of caustic, so those costs to your company, won't change on your behalf. But you can reduce your maintenance, costs by actually employing these things. So we're rolling out, and I'll just ask my team somebody to leave the link in the bio, in the contacts, where you can actually get in touch with me, because we want to be able to train you on how to actually explore these opportunities. As Shauna-Kaye said, it takes years of training. But what you find now in those years of training and those years of experience, that now can be shared, because you on your own won't develop that overnight, right? So for example, in my years of operation, I mean, there are times when you detect something based on the vibration analysis, for example, and then you take the equipment out of service and you look and you say, oh yeah, that's actually, when I saw that ball pass frequency in the vibration spectrum, it was actually, it was actually the cage rubbing. There's some other things that you learn over time, as Shauna-Kaye was mentioning, and some of this, can be passed on in terms of training. And to police the system, as Rossi said, another way we police it, is if somebody comes into your industry and say, take out this motor because it has a fault, you need to actually see, as Vansy said earlier, people tend not to believe in it because that they can see today, but once it comes out, you need to see and verify and bet that yes, that was actually the fault that was recommended. You understand? So it can actually police itself to some extent if you have the expertise. So yeah, man. So we will, as I said, my aim in all of this I want, Jamaica and our industries to be competitive, regionally and globally. I think as Shauna-Kaye mentioned earlier, technology has been far, far gone ahead of us. Even the car that you drive today. I mean, cars in the States are electric now. We are still, using petroleum, and over time, we need to catch up. The technology is just far, far advanced. And, as Shauna-Kaye said, when to get into AI, right, artificial intelligence, you need to have this framework set up where you can now pull on. Because if you don't start today, you don't start now, and you say you're going to start next year, you have already lost years of data that could guide in terms of, maintenance strategies. The history is very important. Thank you.
All right, thank you very much. Vansy, you have something to add to this?
Yes, then just to add, the university and the colleges, they prepare you for broad spectrum engineering, for broad spectrum employment. They give you the background, they give you the foundation. So when you come in the field and you pick your path, your aim is just like you want to be the best in your class, your aim is to be the best at what you do. So the learning continues. So each industry is learning specific. So it is not UTech or UE would not give you, or Maritime would not give you that tailor-fitted approach for this industry or for that industry. What it does, it gives you the base to learn. So once you get in that field, you apply the theory you have, the Ohm's law you had from there behind, the bearing issues you had, the bearing theory you have. So don't say you just left school, so you don't know you have the bearing operations. You know the different type of bearings. You know fluids. You know lubrication operation. You know about the soaping of it. You know about the liquidization of it. You know about the how fuel reacts. So you will apply this based on where you are, and then add the experience of past mistakes, past success, and just grow yourself. That is where the industry comes in. But you will never be able to. You get to use the equipment. You learn about the basic meters, but specialized things you have to learn in your specific job. That's just adding to what everybody has said before. But specifics of the industry, Rossi's keep reaching it. I want to get it. He's saying that when you're in a field, you learn the specifics and be the best at it by doing the best practice in it.
Great. Shauna-Kaye.
Thanks for that, Vansy. But I actually wanted to ensure that one thing is addressed or one point is we expose one additional point regarding predictive maintenance. A lot of us kind of overlook it, I believe. It is installing a new piece of equipment. Data suggests, literature has bantered on and on about it, reliability literature. The first couple days or hours of operation is the riskiest. That is when we are at the greatest amount of risk for what we term in the reliability field as infant mortality. Now, predictive maintenance is very critical at this point. So I hear it a lot, oh, we buy this new piece of equipment and as it started up, or as it not even run 1 week and it started trouble. The commissioning aspect of a new piece of equipment, the value is in the commissioning. So that reliability that you're expecting has to be from the first button that you press, outside of design, of course. But the first button that you press to energize that circuit, you have to be monitoring critical data at that point because you risk infant mortality, and predictive maintenance can do that for you to give you a baseline so that you know from there on, you know when performance dips, and you know when you ought to be alarmed. All right, wanted to add that.
Wonderful, thank you very much. And let me bring you back here, Mr. Brown. All right, let's talk a bit more about motor acceptance and testing awareness. Can you weigh in on this?
All right. When a motor enters your facility, or before you even think of buying a motor, you know the specifications at which you want that motor. You know the size of that motor, the frame, the horsepower, the output you expected. All of this comes back to the basic thing of voltage, current, and resistance. So you will do an acceptance test. We call it baseline, and we record those values, keep it there. Once a motor has been run for probably 100, we normally do baseline. Some facilities do 75 hours after running baseline, but for And I'm a small company, you install a motor, it's running, you give it 180 days, which probably work out to be 6 months. You do a next test on it to see how it's operating, but your bearing checks and those things will be checked like every week or every other week based on its operation and how severe it is. But the electrical section of it, which in terms of the supply cable, the junction box, the switches, the windings, those you check every 180 days. And you record and store those values because that is where you're gonna do your trending from. When a motor starts to fail or a joint starts to fail, it starts to give off a higher temperature at that failing point. That's based on theory and also experience. There are some sections of the motor which is normally expected to be warmer than some. That's what you know from trending. You say this motor, the section in the middle is always warmer than the section to the back of the motor where the fan is, but going to the drive-in, it's a little warmer. So you actually record your temperature profile. Acceptance criteria comes in, you have your figures from if you're using whatever standard you're using or whatever requirement you have for that motor based on the manufacturer's data sheet or the sheet you get with that motor saying that, well, motor, the nameplate. So you test, compare the nameplate values and also data sheet. So that's what you call the acceptance criteria and you trend along that line. But as I said,
if I may weigh in, Vansy, just a little. The concern I think we have in the industry is the integrity, because we do a lot of rewinding here, because we are trying to save money, of course, and of course with every rewind you lose some amount of performance. So how do you track that? Because you have entities that rewind motors several times, right? How do you check that you're getting quality from a supplier?
That's a very, very, very good point, because we have to outsource what we can't do. So we need help, and we have to trust, and you have to have integrity. When you send a motor to the repair shop based on your failure test and saying it failed in the field, it failed in the operation, or whatever it is, and you get that motor back, you would already have a baseline information on that motor. You compare to the baseline. What I've practiced and my other coworkers have practiced is that we tend to be a little lenient with some of the figures as the acceptance figures, because we know that when a motor goes to the shop to rewind, it gets burnt out, you lose magnetism, it loses some amount of efficiency. The resistive imbalance, those things, we ensure it's on point. There are some things, the air gap, those some things we do not take for granted. But in terms of the resistance value at new compared to rewiring, it's okay to go up a little, but all phases must be balanced. So we check for balance phases, balance resistance values. We look at the capacitance of the motor. We look at the meg ohm value of the motor, which is how good the insulation is, the PI value, which tells you the health of the insulation. That will tell you your life of your motor once you put it back in the field. But remember now, a motor going back in the field has bearing issues to deal with too. It has alignment issues, it has balancing issues. So when the motor comes in back to your facility, you have to also have a facility or a feature of how you test your bearings, or you test your rotation, or you test if you're getting the motor speed up to the right speed based on nameplate. Losing magnetism, we can lose some amount of torque based on our efficiency gap. But what I'll say, some things you cannot take for granted or give play with, like resistive imbalance, inductive imbalance, and we also have the sine waves, which you have, they call it electrical signature analysis. It tells you if you have imbalance in voltage condition, the motor, phase to ground, and those things. And that's where you're actually comparing it to nameplate plus your baseline information. So when the motor leaves your facility to go to the repair shop, you have a failed result. When it comes in brand new out of the box, you have a new result. All those results data you'd have in your system already. So you decide to compare it and say, when the motor left here to go repair, let us come back to compare it to as new condition. You should not be looking where it's in caution, but they say, okay, rain fell, so the motor winding might be a little cold. Let us see what the insulation is reading. So these are the things you compare to based on your facility and what you're used to getting when the motor was in typical tip-top shape. But once you do rewiring, you're losing efficiency. But as we say, condition-based monitoring is to prevent us from over-maintaining and under-maintaining. It's about finding a sweet spot. So we say, if we rewire this motor 10 times, we might not go back for the 11th time because we're losing out on efficiency now. So we're going to use more power to operate. So it's less productive right now. So we should find a sweet spot within your organization and how you can operate and how you plan to invest in terms of your machinery. Did that cover it? Well, I'm still here. I can answer some more.
Yeah, man, Mr. Mendez wants to weigh in on this one. So I guess he wants to add it to see if we can answer that question as well. Mr. Mendez.
Yeah, I just wanted us to not miss, a point that Vansy was making. I think that's where the gap is. Oftentimes, you send an equipment out for repair and you get it back and you say, yes, it is new. And nobody actually, as Vansy mentioned, nobody actually checks to ensure, do we compare it? Do we compare it against what was there before? What's the acceptance criteria, right? So when you get an equipment repaired outside of your company, when it comes back in new, you can't just take it and say, okay, it's new, let's put it in. Even for new equipment, there are times when there are changes from the manufacturer that is not in line with your operating, conditions. So you must always be disciplined enough to check and verify. Because once you put in that equipment, and you take out, for example, the motor comes back, and you say, oh, it was repaired up the road, it's, the good guy. And you put it in now, and you're running now. Now, when you find that there's a defect, there's a downtime to be had to actually take it back out, right? So, and then by the time you're running it, the person can say, well, you put it in, I don't know what you actually did. So you have to just be disciplined in terms of maintenance, to check and verify. That's it.
All right, good. I just want to remind the participants, you don't have to allow me to ask a bunch of questions. You can also ask your questions and I'll read them out for you. Or if you want to unmute, I can unmute you and allow you to ask, your question. All right. But I just want to bring back Mr. Ramsaram on this one. All right. We've been speaking a lot about predictive maintenance and all of that, but could you tell us a bit more or weigh in a bit more about prescriptive maintenance?
So on the prescriptive maintenance side, I think Shauna-Kaye went into some depth with it already, is that you need to have valid information to make valid decisions, right? And if you can't make those informed decisions, then you're going to end up with running to failure or just having persons do what they do at any given point in time. But for example, when you do vibration, there is no, as Vansy was saying earlier, there is no ideal point like in electrical where IEEE would have specific values, or you could adjust the emissivity on a camera based on the reflection. There is no training that will tell you ideally that 1.25x is a bearing fault or the bearing race, right? You have to be intimate with the equipment as well. So if I come to your plant and I have to do vibration, I want to know as much information as I need, as I could get on that piece of equipment to make an informed decision based on the data collected. And it's all about the information that you see in front of you, right? An example is this. We do some vibration for a company that entails some rolls. And each month you would see various different readings until we came to the root cause now that the operator is actually not using the equipment properly. That is causing premature failure. So we would prescribe that they do some training for the operator in the use of the equipment. So you see, this goes back not only to the equipment or not only to the motor, but to the persons operating this as well. Because we get so tied up in what we do, believing that what we do is the correct thing that we do, until we just realize at some point that is not correct. You only know, or you can only do what you were taught. This I understand. But you need to take the prescriptive aspect now to the right people to make the decision to have sometimes organizational change and not only equipment and maintenance changes. So it's a lot bigger than just the maintenance. Thank you.
All right, Shauna-Kaye?
Right, I wanted to add to that. Thank you so much, Rossi. So as engineers, we are the persons who prescribe based on the information that we would have gotten from a predictive finding, right? So we collect the data, we do some historical trending, and we look at what the piece of equipment has been doing over the last 6 months. We take the recommendation from basic literature. If you see this, then this is the issue. If you see that, then that is the issue. In terms of our recommendation or prescription, right? And as I mentioned before, it takes years of training to really interpret the data on such an accurate level, for lack of a better way of putting it. It takes years. So we are less, as engineers, we are, let me make the distinction. As engineers, we are not experts in predictive maintenance, analysis, and data collection. As predictive maintenance technicians or predictive maintenance engineers, we prescribe. What if we could eliminate the need for deep analysis by using data edge computing? It is a world that we need to dip into, because the computer can tell us what to do. The computer can use the data and say to us, we need to change the high-speed bearing. And also, we need to change the frequency with which we do this particular preventive maintenance activity. And that is the future of maintenance, prescriptive. We're not there yet. Trying to get over the predictive hurdle first. Prescriptive is unnatural. So it is using edge computing to tell us exactly what we need to do, pulling information from every point of data. So it looks at the temperatures, it looks at the pressures, it looks at the usage, the running hours. It looks at the last data, the historical data for the last 6 months. It looks at the mean time between failure and say, here what, do this. That is predictive prescriptive maintenance. And currently, experts in the field are doing that, but the computer can do it in the future.
All right, thank you very much, Mr. Ramsaram.
So Shauna-Kaye, you were talking about the data analysis via the computer. Now, inevitably, you still need to have someone there, because we will be out of a job, right? But yes, it could be done. For example, Proof Technique has their system where you can set up all your points. And once you download this data onto it, you just click on it and you would see it maps out what are the problems, right? Based on SKF or FAG or whatever bearing type you have. But one of the things though, and I think you would agree with this one, is the experience for certain aspects, for example, as Mr. Mendez said with the pumps, to re-engineer that based on the information that you gather, it's not ideal. So Mr. Mendez, if a computer wouldn't tell Mr. Mendez to re-engineer the pump and change the bearings. For a gearbox, one of the most difficult things to analyze is a multi-stage gearbox. And people don't really go into it because you have to use the FFT, but only to an extent. The raw data and looking at the waveform itself is what gives away your mesh frequency, where Jason Tranter would say in training, you will get the mesh consistently. And when you see the peaks, then you would understand what's going on. But there is aspects for that on Proof Technique, especially since Fluke purchased them over. They did make some advancements on it, but the nitty-gritty part of it, without using the term, you still have to have the person there, the finesse into it, to actually get what you want out of it. Yeah.
That is very true. You know, and as we said before, we could go on and on and on for the entire day speaking about this topic, but you know, unfortunately, we have to wrap up at this moment. But what I will allow now is, you know, each of our panelists to give you, you know, your last word, you know, on this topic of asset management, right? You know, starting with you, Miss Engineer East Bevan. You know, last word.
Right, boy, I've said so much, but one thing, I'll leave it as this. Just one question I have for all the members of the panel, all the members in or attendees, and all attendees, of course, the industry leaders, the engineers, I have one question. Will you be left behind? And that's it.
Will you be left behind? Thank you very much. Mr. Mendez, last words?
Yeah, based on what we went through today, I'm sure persons may have seen the benefits. As I said earlier, it doesn't have to be a very expensive venture. As Rossi even mentioned, the consultancy can be had. I would say just try it and see, where you are, because you're operating, your maintenance cost maybe, let's say 100,000 per month, and you think it's okay. But when you apply predictive maintenance to it, you may see 20,000 a month, and that is significant savings. So I'm saying just try it, and you'll see the benefit of it.
All right, thank you very much. Mr. Brown.
All right. In continuing, Shauna-Kaye, yes, prescriptive maintenance is the way to go, and all of that. But remember, small baby steps. To reach prescriptive, you have to have a predictive foundation. So you'll know what is good, what is good. Because Giga remember Giga? That's something I remember that a long time, Giga. So we need to have a base where we know what is good, what is bad, how do we design our equipment. And we have been through several industries, and the major thing that comes to each equipment, making them unique, is mod. Maintenance, operation, and design. So each equipment is specifically operate in a certain way, and it gives you a longer life on how you maintain it, and also how you operate it. But major focus is supposed to be placed on design. Was it designed for this operation? Was it designed to be used in this space? If it was designed to use in this space, we're going to maintain it properly, we're going to operate it properly, and we're going to have a successful time around this equipment. Surviving bathtub failure, it's all yours for the end of the life. But in just a little 2 lines here, I have to read this because I don't want to slip these words. Routine field testing of windings as related to motors, just to put it out there. And we have seen the result of this. Can identify deteriorating insulation, permitting scheduled repair or replacement of the motor before its failure disrupts the operation. So in all we do, it's about routine maintenance, proper maintenance, and consistency. That's what. And we'll be talking further on this as time goes on. So and thank you for having me. And it was a pleasure being here. We don't now want to get to share these things freely, but it's a good feeling.
Yeah, man. Thank you very much. And Mr. Ramsaram.
I actually want to close and say with an opening statement, baby steps, as Vansy said, but some progress is still progress. I need people to remember that, right? You may not see the $1 million saving today, you may not see it tomorrow, but it is there in the long term. And as the panel was discussing, and they were saying, predictive, prescriptive, and all the maintenance strategies starts with some baseline. You need to have some base to stand on. And what I encourage people to do is build your network. I mean, we all here consult amongst persons like yourself and get information from different plants. I mean, you don't have one plant in Jamaica, you don't have one plant in Trinidad. Talk to the people that utilize it already and let them make recommendations for you, for equipment, for people. And then you could take it from there. You could build your system to take to your management. And always remember this, old boss of mine used to tell me this, anytime you hear a no from your managers, it's an unjustified yes. So you need to justify properly. Yeah. Thanks again for being here.
All right. Thank you very much, all our panelists and all our participants for joining us. It's this first of many other webinars and seminars that we'll be having, for this year's council. Our theme is engineering being the driver, of manufacturing, production, economic growth, and health. And with this particular session, its theme being asset management using predictive maintenance for productivity and profitability. Look for more seminars to come. Follow the Jamaica Institution of Engineers on all its social media platforms. And if you're not a member of the JIE, now's the time to become a member. Right. So on behalf of myself, Michael James, on behalf of our president, Engineer Godfrey Boyd, and the division chair, who I'll hand over now to. Thank you very much for joining us.
Thank you, Michael. And you've said it all. My wish from this session is that every industrial leader, every engineer thinks on these things and applies small steps to ensure that our economy stays viable. We play a part as technical persons, and I wish for fruition for the manufacturing sector or the design sector. Anything having to do with production and productivity, I wish for excellence. And these are the things that we need to think on implementing to get to that point. So that's what I want us to take away from this session. And the JIE is very passionate about that. And the Mechanical Engineering Division and Council President and the PERB Engineering Board is also passionate about this. And we're willing to play our part in advising the public about these technologies that will help us to progress. As Mr. James said, thank you so much for joining. And we look forward to more of these sessions where we can interact with you. Thank you.